Welcome to our today's webinar on AES67 Practical, how to configure switches properly. Last week, we have learned from Claudio Becker-Foss from DirectOut what you can do and what to look after when configuring AES67 devices. But of course, the network itself is another very, very important part of the game. So today's webinar is about the network stuff. I have a few experts with me: Claudio Becker-Foss again from DirectOut, Bart Swinnen from Luminex, Nicolas Sturmel from Merging, and myself, of course. For those who don't know me, my name is Andreas Hildebrand. I'm working for ALC NetworX out of Munich. We are the guys who invented the RAVENNA IP media networking technology 10 years ago. And most of this, if not all, has been the basis for AES67 and ST2110 anyway. So let's jump into the topic, today's agenda, just to give you a brief overlook. We have an overview on the important network configuration aspects, which includes multicast, quality of service, virtual LANs, and of course, precision timing, the time distribution. We will then jump into practical sessions. We will see Nicolas Sturmel explaining configuration of a typical office switch on a Cisco SG350. Bart Swinnen will explain how to work with the Luminex gigacore switches, and Claudio Becker-Foss is jumping in with the RTEL Quara, which is a very particular switch supporting enhanced PTP, and so he will show parts on that aspect. A very important hint here, we have a Q&A function in the GoToWebinar. So if you have questions anytime in between the webinar, please use the Q&A function and shoot out your questions to us, and we're happy to answer them. We will have smaller Q&A breaks after each practical session, and we will have, time permitting, a larger one at the end. So whenever something pops up in your mind, just use the Q function of the Q&A section and shoot out your questions. So let's jump in directly into the topic. First of all, we have to deal with multicast traffic on the network. Well, for those of you who are not sure what multicast exactly is, multicast basically is a packet distribution where one sender talks to many receivers. So we have the traditional or the most standard way of communicating on a network. One sender talks to a particular receiver, that's called unicast. Multicast is the situation when one sender can talk or is talking to multiple receivers. And don't mix this up with the third way of transporting data on the network, which is broadcast. In a broadcast situation, a sender is talking unconditionally to all the receivers, at least in its local network segment. So the benefit of multicast is it scales compared to unicast. How's that? Now, in a unicast situation where we want to transport content, the same content from one sender to multiple receivers, we would have to send out a number of identical unicast streams to reach each of the intended receivers. In a multicast situation, the sender is just sending out the stream once, and the network is clever enough to distribute the packets to all the receivers who subscribe to this particular stream. So as you can see, in the unicast situation, we have quite a lot of traffic, even it's all the same traffic on the network, where in the multicast situation, that particular content is distributed on any link in the network just once. So it scales perfectly. However, there's also a risk. It can flood. And I really mean it can flood. Why is that? Well, because unmanaged multicast is basically the same as broadcast. So what may happen is, if you have a 1 gigabit traffic flow, let's say on a gigabit Ethernet network, so it's a flow which is close to the, well, it's about the maximum limit. What happens in an unmanaged multicast situation is the switch most likely will distribute the incoming traffic to all the outgoing ports. So it will copy the incoming 1 gigabit and fill up all the egress ports with traffic. Now, that certainly may overload links, particularly if you have more traffic coming in than just the nominal 1 gigabit, let's say on 2 ports, then the switch will try to distribute the 2 gigabit of data coming into to the ingress ports to all of the egress ports, and that certainly won't work because, well, nominally you only have 1 gigabit speed on the ports, so it will overload the ports and will definitely drop packets. So, and of course, that's not only a challenge for the switches or the network itself, it may also evenly overload end devices. Let's assume you're running a video stream, which let's say has 300 megabit per second and a 10 megabit per second audio stream. That's nothing for the gigabit Ethernet switch. Well, but if you have unmanaged multicast, the video device will not just receive the video stream, but also the audio, which is probably not a problem for the video device anyway. But, well, what about a speaker which may be connected to the network and just has a, let's say, fast Ethernet link, or, well, maybe even a gigabit link, but that certainly will be overloaded with the total amount of traffic, because usually in a speaker you wouldn't find a network controller which would be capable of dealing with such high amount of traffic. So it may flood, and flooding is something we definitely want to avoid. However, AES67 definitely uses multicast for streaming as well as for the PTP distribution, and so that means we have to manage multicast on a network. How's that done? Well, we have something which is called IGMP, the Internet Group Management Protocol. What happens is that we have a switch. Let's say we have a switch here with 7 ports, and we have a multicast transmitter, some non-interested devices in that multicast, and one particular interested listener. So how do we manage the multicast network? Well, we enable IGM snooping on all ports, on all switch ports, and the multicast transmitter just starts transmitting. As long as no one is interested or has subscribed to that particular traffic, the port just, or the switch will just dump the incoming multicast packets because it doesn't know where to distribute it, and so it's not forwarding it at all. So in order to have the interested listener subscribing to that particular multicast stream, we need an IGMP querier. The querier can be enabled on a switch or on some other device in the network, and it will send out IGMP queries. Basically, it's asking, it's sending out a network control message to all the connected devices, and it's querying who is particularly interested in what kind of stream or what particular multicast stream, and then the interested listener can just respond with an IGMP response telling the switch that is interested in the multicast stream, particularly coming from this multicast transmitter. So, and then the switch forwards the multicast traffic to the interested listener, but does not forward that traffic to all the other ports. So with that mechanism, we have a nice, clean multicast forwarding of traffic without overloading or flooding the network. So the next important aspect on anything with the AES67, RAVENNA, or ST2110 networks is quality of service, QoS. So the goal definitely is that we transport our media, and particularly our PTP packets, with the lowest possible latency in the network, and also we want to minimize the packet jitter on the network, particularly for the PTP protocol, because the accuracy you can achieve with PTP highly depends on what packet jitter those packets receive while traveling on the network. And the secret behind it is using quality of service with expedited forwarding for those precious media and PTP packets. So the problem here basically is switches are usually not aware of the traffic type, so all the IP packets they receive basically look the same unless you use QoS. And for IP-based traffic, we have the differentiated services, or short diffserv mechanism, where you can basically tag IP packets with certain traffic classes. So the switch then given that it's properly configured, can identify the DHCP tags of each individual incoming IP packet, and it's then storing the incoming packet in prioritized forwarding queues on the particular egress port. So it's basically telling or sorting the incoming packets towards the prioritization. And then on the egress side, on the output ports, the switch supposed to use strict priority scheduling on egress. Here's a diagram. Let's assume we have a 4-queue switch. That means that on each egress port, outgoing port, a switch has 4 different priority queues. And the scheduler uses strict priority queuing. That means whenever there's something in the topmost or in the highest prioritized queue, those packets get served first. So, and then we just to make sure that any of our devices, PTP or streaming gear, is tagging the IP packets which carry the media data or the PTP have related priority or DHCP tags in their IP headers. So then the switch is looking at those IP tags. Let's assume that the PTP packets receive DHCP 46. So the switch knows, okay, any packet with DHCP 46 goes into highest queue and is being served first. And Nicolas will elaborate on that further in the upcoming section. So that is how quality of service works. Quality of service may also be helpful to avoid packet drop of prioritized packets on those networks which receive a high load or a temporary overload at times. But again, or to underline, it's no guarantee. So QoS, DiffServ QoS is not a guarantee that no packet loss can ever happen. But it's a good measure to also prioritize packet loss, packet drops, so that packet drops happen or occur in the lower priority queues first, where it usually doesn't harm. Now, if that all sounds very familiar to you, well, it is. Everybody has experienced this situation, albeit not within the recent month, hopefully at least. So if you think of boarding an airplane, you have a first class queue, a business queue, and then a economy class queue. First class passengers are usually allowed to enter the plane first. They are called by the egress scheduler on a strict priority scheme. Only if there's no first class passenger waiting, then the business class passengers are being served, and so on. And whenever a first class passenger comes again, he will be the next passengers going over the bridge, even if there are others. That's the quality of service, differentiated services. Now we have another aspect which might help planning and setting up networks. That is VLAN, which is basically there for separating devices and traffic apart from each other. Now let's assume we have a nice switch here, and we have connected some gear to the switch. We have 2 office PCs, which have office traffic, like, web mailing, file copies, and so on. We have some audio devices on the network, a microphone, mixer, speakers, and we have a video device, a camera and a video display, which should receive the camera stream. Now, and then, of course, there might be further networking connected with a trunk line, a port which is designated to be the trunk or the connection line to further up or down network gear. So what happens? Well, the office PCs can talk to each other, the camera can talk to the display, and the audio gear can talk to each other as desired, given that we have a non-VLAN situation here. So every device is basically able to receive traffic from every other device. Now, what also can happen is that the office PC can send traffic to the mixing console, or the mixing console receive traffic from the office device, which is probably something you don't want to have, actually. And neither you want to have something like camera streams hitting the speakers. And so you definitely want to set traffic zones where you can isolate the devices and their traffic from each other. And you do that by creating virtual LANs or private LANs on the local network. And this is done by assigning VLAN groups to individual ports or devices. So you can set the office PCs into one group, you can set the camera and the video display into another group, and then you can assign the remaining ports towards the audio devices. So what happens is then it isolates the traffic among the ports, and there is no traffic interference ever. So the office traffic cannot hit into the audio regions anymore. So basically, tagged or VLAN tagged traffic packets cannot cross into other VLANs. Well, sometimes that is desired, but that is one of the drawbacks of VLAN. If you definitely want to have traffic being able to cross the VLAN boundaries, you have to have a routing capability, a router or a routing capable switch in the network where you can set up what particular traffic is allowed to cross the VLAN boundaries. Keep in mind, VLANs is a nice tool to set traffic apart from each other, but it doesn't help you with bandwidth overload. For example, if you overload a switch backplane and then or the trunk, which is what most of the times may happen, then you will experience packet drop. So VLAN can separate traffic from each other, but it may not help you much with keeping traffic in its bandwidth limits. So finally, PTP is important. The PTP is used for the network clock synchronization. Here's how it works. We have a device A, which needs to generate a media clock, let's say 48 kilohertz. We have other devices on the network where we definitely want to have the same media clock on all, the same precise media clock on all these devices. How do we do this? Well, we add PTP to the network. PTP is used by RAVENNA AES67 and 2110 as the synchronization protocol. What is done actually, each device has a local clock which keeps time, which carries time, and out of this local clock, the media clocks are locally generated. So we're not distributing a media clock across this external word clock cable. We generate the media clock internally from the local clock of each individual device. So our task then is to synchronize these clocks towards a master clock or a common reference clock, and that's what PTP is being used for. With PTP, we make sure that all the internal clocks are precisely synchronized against the common reference clock, and once that is achieved, all the generated media clocks are precisely the same. That's how PTP basically works. That requires that a common grandmaster is being selected by all devices. This is part of the PTP standard. You might have heard about the best master clock algorithm. Then for those who set up a network, and Claudio will definitely explain that in more detail, you can choose to go with a dedicated grandmaster device as is being offered, for example, by Meinberg, or a more affordable one by Sonyfax, or most of the AES67 devices are also grandmaster capable and can act as the common reference clock for the rest of the network. So, and then of course we, as mentioned earlier, we need to make sure that PTP packets travel with the least amount of jitter, and that's where QoS kicks in, or where PTP-aware switches may help you, particularly in larger or heavy loaded environments. And Claudio will highlight on that. So that's as a first overview and introduction into the topic of today. I'll pass it over to Nicolas Sturmel from Merging Technology, who will tell you a bit about how to avoid flooding and how to hit the right lane. Quick introduction, Nicolas is working for Merging Technologies, who are designers of one of the finest analog to AES67 conversion devices, the Pyromix digital audio workstation, and Merging, based in Switzerland, is there for 30 years this year. Happy birthday, by the way. And yeah, Nicolas will take you into the topic of how to work with a manageable office switch. So Nicolas, you should be able to take it from there.
Absolutely. Hello, everybody. So let's talk about the Cisco switches. So of course, when asking the question which switch is the best for AES67 and RAVENNA and so on, there's no simple question. But one solution that arises is the use of really off-the-shelf, that is, of any local store of the shelf. I mean, even on Amazon, you can find Cisco's from every vendor. And so using a Cisco switch, and especially the small enterprise version that is the SG350. And I did before that the 300, the 500 series on the rise. They are cheap, they are powerful enterprise switches, and they are even called routers because they can do routing. So that seems to be an interesting solution, but it's a Cisco style configuration. So it's pretty complex. There are many different boxes to tick, and it can be tricky. So that's the down. The up is they have high versatility, and they go far and do really complicated stuff. So it takes time, but it's rewarding. So if you have time to experiment and put into such installation, it may be worth. So that's what a Cisco switch is, for those of you who didn't see one before. This is the 10-port version, so if it's an half rack, of course they have many different versions, and as long as it's 350, all those tips and tricks given here are the same. And of course, this is the welcome page of the switch that we will see after. So the first question is, do I need to have a networking degrees to configure it? Because of course, when we talk about IT, networking, and media, and you saw that on Andreas' presentation, there's a lot of different acronyms: PTP, IGMP, ARP, DHCP, etc. And it can be challenging to learn everything and to be able to tackle everything with the right approach. So at merging, we still wanted to be able to offer our customers to use the SG350. And for that, we provide the simple switch configuration that does the trick. So this configuration file is everything you need to configure the switch to start right away, using the switch on the network with the right QoS, the right IGMP, etc. So end of my presentation. No, of course, I will show you how to do this. But if you want the pre-made configuration, it's of course available to everyone on the merging website. You could also use a network design tool, and there are tools that propose direct configuration or that generate configuration files. And this is great when you know where you are going. You are taking a plane, going to a venue, you know exactly which switches will be used, what port will be used, etc. And so those can save you a bit of time. And then this is what we will see today, is the hand configuration. And it's useful to be able to hand configure a switch, especially if you are installing a setup with continuous changes. So the news broadcast, sedentary setup that evolve over time. And of course, it's much easier to be able to understand what you do in the switch to be able to follow the evolution of your setup. So the reverse is true also. Cisco is far from being the best brand when you want easy and fast setups. And that's the thing I tell to my students when I tell them about networking, is that go for the quick setup brands and the brands that are specialized on quick setup if you don't have time to investigate possible network problems. Okay, so let's dive into the configuration, and I will quickly show you all those points, but mainly we will focus on IGMP and QoS because the other points are most likely covered by every Google results that you would see and you would find. You're looking for Cisco SG350 setting IP, 350 power saving, 350 VLANs, etc. IGMP and QoS, on the other hand, are less frequently used in classical IT, so it's worth taking a deeper look. And first, some comments. So, of course, IGMP is not necessary in every cases, and on setup like this, when you have a 10-port switch and only 2 or 3 ports populated, why would you even need IGMP? So if you don't need it, well, just don't use it. IGMP will be treated as broadcast, and of course it's bad. It's bad if you have high traffic, more than 100 megabytes of traffic. But if you have a low channel count, well, it just might save you time. And but the good thing is that IGMP allows distribution on the branch of the networks. And for instance, here I have a software that allows me to see my network, and you see that this Montone device that I have here on my network, when I select the different RAVENNA streams, I see that they are coming up from the Montone to the root switch, which is my IGMP carrier. The bad side of that is that, of course, every switch, every flow is brought up to the root switch, even if it is not used. For instance, I have this stream that is going from the OS to my PC, and even though it's local to only this switch, it will still be brought up to the root switch, and this is just how IGMP works. So you need to always take care of the bandwidth from IGMP. And then you have QoS. So as Andreas said, QoS is nice, but you should see it as an insurance. Basically, when it kicks in and when you notice the difference, it's already too late and you should fix something on your network. I see QoS as a seatbelt, security belt, or an insurance. You need to have it on, okay? You need to pay your insurance every year. But of course, it's better when it's paid for nothing and that you don't need to use it. So, of course, it reduces the damages when it goes wrong, but it's not really the best solution. And for instance, so you have those queue there, and the highest priority queue is there. And those packets, they are basically all arriving at the same time. And but this one is arriving a little bit earlier than the other ones. So the switch begins by passing it through first. And of course, because it passes it through first, the switch has to wait it for being totally transmitted before transmitting another packet. That's the way Ethernet goes. You just don't stop the transmission of a packet when you have a higher priority packet. And this is problematic because if you have long packets, and the packets can be up to 1,500 bytes, that's 12 microseconds. So you can have up to 12 microseconds of jitter, even on the best quality of service network, and only with one switch. So when talking multiple switches with high number of streams and really big packets, IGMP will not be enough. QoS will not be enough. And moreover, you have those little tricks that, based on the protocol that you are using, you have some refinements and some collisions on what we call the DSCP that I will show you right after. And AES67 is using expedited forwarding for PTP, while Dante and RAVENNA are using expedited forwarding for audio. So of course, this is problematic because at some point, the audio and the clock may be in the same queue of the switches. But of course, most RAVENNA and AES67 devices are configurable to a certain extent. So in the end, there's not really any real-world effect because you will take care in configuring the device properly. Okay, so back to the demo, and let's show you the switch. So this is the main switch of my network. So my IGMP carrier. and I'm starting in basic mode, basic display mode, I can go to IP configuration and to the IP interface, and I can add or modify the IP interfaces of my switch. I can go to the VLAN management to manage the VLAN, and I can, of course, go to multicast and quality of service. So first, multicast. So using multicast, I have to enable snooping, multicast, enable carrier status. And of course, I have to check that bridge multicast filtering is enabled. Thankfully, the switch does tell me to wait for it, but unfortunately, I can only access bridge multicast filtering through the advanced mode. So by default, bridge multicast filtering is enabled, but it's not necessarily enabled in the right way. So let's go back to multicast and choose bridge multicast filtering using IP group address. This is the best way to filter the IPs because multicast packets have both specific MAC addresses and IP destination addresses. And there are some collision between the MAC address and the IP address, so choose the IP address. Then you go into IPv4 configuration, because of course that's the only one we are interested in right now for the moment. And so enable snooping and querying status. And on a VLAN, then you will have the different status of your query. If the query is activated, it must be administratively activated and operationally activated. That is that you can ask the query to be activated, but if it finds another query on the network, it will automatically be disabled. You can see if the discovery of the router ports, that is the upstream switches where you basically give out the multicast, as I show you here. The router port for this sleeve switch would be port 9 here to the root switch. So you can choose to use auto discovery or not. And then you have all those configurations there. So let's get a look. So here, and you have, for instance, the query robustness, which is the number of times the switches queries a device, and the number of times the device should not respond that it wants the stream for the switch to shut the stream on this device. So since I have some enabled and some not, I generally don't like to enable mRouter ports and query election. For me, it's better to control your setup if you are in a multi-switch environment. Of course, if you are only using one switch, it doesn't really matter. But if you're in a multi-switch environment, you could be exposed with some very strange behavior if you trust the automatic discovery of Cisco switches. Then that's it. You can also, based on the ports, you can change the different timers. So the query interval is the time between two different queries. And it's 125, but it's bad, it's wrong. It should be 30. And you can do the settings based on VLANs. So this is why you edit the query interval. Use the smallest query interval you can. I think in this switch, it's 30 seconds. Yeah. So that you get the maximum responsivity on the switch when you add or remove devices. Then you can leave basically everything to the default, which is the case here. Okay. And then you're set. So it's not really that complicated, but you just need to know where to tick the boxes. And if you forget a box to tick a box, of course, it can be messy. So we can, for instance, just remove the query and the snooping and see what's happening after. And of course, I remove snooping, but I can still configure my interfaces. So from the user point of view, I don't really necessarily see what's wrong on my network. Then there's quality of service. And for the quality of service, you have multiple modes. So you have the basic mode, the advanced mode, and let's use the basic mode because it's enough. You can configure the queue scaling, and using strict priority is a good idea at first, and then you can always micromanage if you need it. The class of service is not used there because it's a VLAN QoS, and we are using DSCP, differential code point, as a QoS. It's the code point in the IP header that we are using to classify the packets. And you remember here the data that I shown you before, 56, 46, and 34, and that I use here, 56, 46, 34 here. So what we did in the merging configuration is that 46, which is kind of a hybrid class for us because it's both PTP clock in purely AES67 and audio packets in Dante and Ravenna. We did it on a specific, we put it on a specific queue. So we have Q8, the most priority for 56, 46 for Q7, and 34 for Q6. So basically, first the PTP clock, if there are any, then the AES67 clock or the Dante packets, and then the audio and Ravenna, of course, the Dante and Ravenna clock, the audio Dante, the audio Ravenna, and the AES67 clock, and then the AES67 audio. And one thing you need to do, where was it? I had it just before. Oh yeah, it's there. In the basic mode, global setting, you need to choose the trust mode to DSCP in order to tell the switch to not use the class of service, which is in the in the VLAN header, but the DSCP, so the differential service code point, to use QoS. And then that's all, and you should be able to see in the statistics what's happening on your network. So for instance, here you see that I have packets on 5 different queues. So Q8 is my PTP, Q7 my audio, and Q6 my other audio. I think I have 2 different class of service streams on the network. Okay, so let's see if we have some things that went on the network. Yes, so you see, for instance, there we have removed the IGMP querying on the switch, and then on the ORUS, when I click off any of the streams, they are not discovered and not forwarded by the switch anymore. And if I go back and I do that again correctly, so I multicast, IPv4, IGMP snooping, I set the snooping and the querying, enable them both, and at some point it should be going, so maybe this time or the next time it should be back. But let's not waste time and go front. So okay, so quality of service, multicast. Those are the 2 things that you will care to set up in your switches, mainly using the Cisco switches. So to sum up, pros and cons. Pros, of course, they are cheap and they fit easily in larger infrastructure. If you need to fit in an infrastructure with larger Cisco switches, well, they will just blend in, and they are highly customizable. You can really do almost anything. So maybe you saw on this switch, I had multiple VLANs. I have routing between those VLANs. You can basically do what you want, but of course, that means that you can basically mess with the network without knowing. And then the cons, they take very long time to skill to configure. So time to learn the skill and time to configure. They have no PTP support. So this means that even with QoS, you will not get the best PTP clock, especially on the multi-switch system. So I'm sure Claudio will talk about that later, but what I recommend is that at least some number of layers of switch at some point have a boundary clock or a transparent clock. And limited resources. So when you try to have a Cisco 350, for instance, as and you see it's back. When you try to use a Cisco 350 as a root switch, you have to take care of the number of multicast groups it can handle, for instance. So I think it's 128 or 256. So it's not that much when you have 1 or 2 switches, but when you begin having 10 different switches, then it can be tricky. So take care of that also. So yeah, the trick is that, for my opinion, is that SD350s are really for long-term installation or pre-configured setup. And that's it.
Yes. All right. Nicolas, thank you so far. We have a quick Q&A break. If there are any questions, we might answer a few of them. Roland, did you browse the questions? Have you something you want to shoot out to us?
Yes. Hello, everybody. I'm handling the questions for everybody here. A couple of questions have come in. Olivier asks, if you're using jumbo frames, does that introduce jitter?
Well, it's as shown before. So the packets are even bigger. So the possible jitter introduced in the switch, in the packet forwarding using QoS, is even bigger too. So jumbo frames is 9,000 bytes, I think, at most. So that would be in 60 microseconds, give or take, something like that. So yeah, bigger jitter. But the fact that with jitter, it's really depending on the shape of the traffic. And if the jitter distribution is a nice curve, I forgot the word, but as a nice probability distribution, you can really just negate it by the proper filter. The problem is when you have just chaotic traffic on the network, and this is where jumbo frames are really problematic. So the rule of thumb is that it's to not use jumbo frames in just any media network.
Okay, thank you for that.
Again, to just add on that, mostly it's not a problem when you're looking at the media packets, at the audio packets. It might become a problem when looking at the PTP, because the PTP packets definitely need to receive the lowest possible jitter when being transported across the network. And so jumbo frames coming in between the PTP distribution may cause further inaccuracy, which may or may not harm the operation. So the general advice is to avoid jumbo packets wherever possible.
Okay, I've got another question from Kaylee, who asks, I was curious about the tool that you're using to view the network layout. It seems to be something you wrote and published on GitHub. Can you give us a bit of information about it?
Yeah, that's it. That's published on GitHub. So it's called media. It's called M&Ms, like the candy. So media network management system, and just look at it on GitHub and send me an email. I needed a tool to view my network, so I designed one, and it's getting better when I have the time some time to spend on it.
Okay, and then one final question, I think, before we need to move on.
Yep.
which is, does this mean that the SG350 does not support video applications due to its lack of PTP?
No, not at all. I wouldn't say that. It was the same when talking about AES67 at first, because PTP was such a novelty when we released AES67. Everybody thought, oh, to do an AES67, you need a PTP switch, and that's not true. The fact is that if you are using extremely low latency video at the scale of the line, the image line synchronization, then yeah, PTP might be needed on the switch. But if you're using video at the scale of the frame or maybe a couple of frames, then PTP is not much more necessary than it is in audio. I mean, as a function of the switch.
Okay, cool. I think we continue and may certainly have further questions at the end. So next up is Bart Swinnen from Luminex. Hello, Bart. Bart will talk about, well, easy configuration and a bit about VLANs. Bart is CEO of Luminex Network Intelligence, which is based in Munich, established in 2002. Basically, it's a Belgian company, and they have been looking into how can they make network configuration easy. And yeah, Bart will tell you how they designed their switches and their solutions to make things easy for setup and configuration. Bart, you may take it from here.
Okay, thank you, Andreas. I hope everyone sees my screen with the introduction of our GigaCore family.
Yes, all good.
So I'm going to take it a little bit different than Nicolas did, where we go from our network switch range GigaCore, which is actually, as we are a manufacturer from the AV industry, we make tailored tools for network distribution, for distributing audio protocols, light control, video control, and etc. So just as a brief introduction, at Luminex, we developed a complete range of gigabit network switches, which is called our GigaCore switch range. They are pre-configured, so all the QoS, the IGMP, redundancy, PTP v2, everything is there out of the box. So actually, when you just plug it in and deploy it, you have it already optimized for example, an AES67 setup. So we'll be looking more into the convergence part and where we need VLANing and how we organize that within Luminex. Also, what we do is that we validate with multiple manufacturers and different protocols in our industry so that we can assure that it works together with that partner, and also that Luminex can build up some knowledge, application knowledge in-house, so that we also can support the application in understanding the application and not necessarily need to talk all the IT savvy language in there. That automatically brings us that we have an intuitive interface. Also, something pretty important in some environments is that we have a very silent design. Our switches do have fans, but they run at a very low pace, and only when needed they speed up. But in general, they are designed to be silent. And as you can possibly see in the pictures, we have models which have directly Ethercon connectivity and rugged fiber connectivity. So also for broadcast environments, OB vans and things like that, deploying audio, video, lighting control applications around football pitches, for example, you can make use of rugged switches. So our switches are designed in a way that you do not need IT knowledge. But I want to, before I go into the configuration, I want to express again the three topics we have been highlighting, because we find it very important that that actually what the switch does in an audio network, because it's really an active component and not just a unit that is just forwarding packets. So like Andreas already explained, the querying mechanism and the snooping. I will also briefly show where our flooding bit setting is in our switch, because as we said, if the switch does not participate in the IGMP query mechanism, the switch actually behaves like a broadcast device. So if a packet arrives and it does not know where the multicast traffic needs to go, it will forward it to every single port on the switch. And that's something we can avoid by setting that flooding bit in the switch configuration. And when I come to that, I will explain as well how this has larger effect, where we see larger effect in ST2110 applications. So first of all, the switch sends out the query, so that's the active role. I do that quickly again. So you see actually the switch is sending that query message, and it's the end devices who need to register to some multicast streams that will reply or join a certain multicast address. And from that point, the sender only has to send the packet once, and it will be forwarded by the switch. So this only works when IGMP is there in place, the query mechanism isn't there, and the snooping mechanism is there. But all that is available out of the box. So I'll also briefly explain how our QoS setting works in a Luminex device. Like Nicolas showed the mapping in a Cisco and how to set it up. What we did in our gigacore switches is that we have a predefined setting, but where actually this table is showing how we work with the 8 different egress queues we have available. This is in a standard setup. We also support AVB with our switches, and then the map is slightly different. That information is also available on our knowledge base, but we still have QoS in place. And I think the importance of the QoS is not to be ignored, in the sense from the moment you start doing multiple hops with your switch. So once you go from one switch to another switch, and certainly in a moment when I'm going to talk about VLANs, which means that we're going to do multiple applications on a network, in a converged network, there is a bigger chance that you have on one switch packets coming in that needs to go out on one trunk port, for example, to go to the next switch and to go to that particular port that needs that information. So the fact that you could have data collision, I totally agree that QoS is a mechanism that helps at prioritizing, but you can still have some jitter, has been nicely indicated by the packet size. But I think it's a very good thing, certainly when you start to scale the network and when you interconnect switches to each other, that QoS is in place. We do have the same challenges here with, for example, where you have the Dante audio packet data together with the AES67 P2P v2 clock data. So they are in the same priority, in the same queue. So there is some challenges there. But I think that's also something that Claudio will cover from the moment we start using P2P v2. A lot of that jitter on that specific P2P packets can be actually corrected because of timestamping in the switch. So that's where, in our case, the switch on the third place. So first we had IGMP and multicasting, then secondly QoS, and then the third place where P2P v2 actually the timestamping of the clock does the correcting. So it makes it sure that the clock stays accurate, even there is some queuing in the switch. But this to be, I think Claudio will cover what we can say in this perspective from Luminex, and I've seen a very extensive seminar from Meinberg, I think a week or 2 weeks ago here on this channel, where they explaining the different clocks and what we have embedded in our gigacore switches, and by default is an end-to-end transparent clock. So this means that by the hardware, the clock packages, the sync packages have in the same packet actually a one-step transparent clock. They have the correction time added. So even the packet has been queued, then the correction is there, and the accuracy remains on the P2P mechanism. Maybe just to add quickly in there, because of the question that just came for on the jumbo frames. Of course, the jumbo frames will cause a larger buffer and a larger time before the P2P packet can go out. Maybe here it all depends also, correct me if I'm wrong, Andreas, but that it depends on how much latency or accumulated latency you want to allow on the network, meaning in presentation time of your audio protocol. Definitely, I would advise as well not to use jumbo frames to avoid this. But again, the correction on the P2P v2 timestamping should be able to correct the jitter on that queuing, the same as we would have where we have colliding Dante packets with a P2P v2 clock for AES67. But well, that's quickly to cover where Luminex is concerning these advanced settings we just went through in the previous presentation from Nicolas. That all these are predefined and pre-configured, so there is nothing to set up for that. So I would like to explain a little bit on a converged network, because maybe you want to use your infrastructure not only for transporting AES67, but you also want to do some maybe light control. You have some AES67 for audio, maybe you have another protocol for comms, or even if you use equipment like Riddell, you have even AES67 for comms in there. You can have some video on the network. So just like Andreas explained as well, the goal is that we can separate this on the network. And in Luminex terminology, we don't speak much about VLANs, which is a virtual LAN actually, but we call it groups. So we going to make a group for each specific application, and then we can assign ports to that. So I'm going quickly through these slides because I want to move forward to our interface and show you how we do the configuration as a demo. So here we have a red group for audio. So we can actually assign all our audio devices to that particular VLAN. Same for the lighting group, the comms, and the video. And then when all this is separated from each other, actually one thing to be done is actually to set up the inter-switch connection or the trunk connection. We call it ISL, so inter-switch link. It's the link between the different switches. In this example, it's a ring connection, as we do support redundancy as well out of the box. So, but this ring connection, this could be a combination of, well, you can do any copper or fiber connectivity, and we can set this up as one particular group, which we call inter-switch link, but in IT terminology, it's called the trunk port, where the VLANs are separately tagged. And all the trunk ports will carry all the different VLAN information toward the different switch. So here is where you can imagine if there is, for example, some lighting control data and some audio control data, that on that particular link between the two switches, there might be a bigger chance that there is data collision, and then to have priority on audio because it's much more time critical than the lighting control, for example. You want to be sure that your P2P packets go before your regular ARCnet streaming ACN lighting packets, for example. And this is well common to any other application where Andreas also mentioned, for example, an office computer, which in general will have no DSCP settings done, so no priority. So in that case, it would be sitting also in a separate group and actually being separated from the other protocol, and QoS makes sure that priority is correct on this trunk connection. So now I would like to take you to our interface actually. what we're showing here is actually our software application called RAVENNA. RAVENNA is an application that discovers the switches and monitors and enables you to live configure these devices in a network. I'm going to use this tool in a moment. I'm first going to show the web interface. So in this case, I have here just next to me on my desk 3 switches sitting connected to each other. This is the out-of-the-box situation. So nothing is configured. They are just been resetted. If I double-click one of the switches, I get to the network, to the web interface of our switches, and you get directly an overview on how it's been set up. So all the ports, 1 to 26 here, I have 24 copper ports, and I have the possibility to have 6 fiber ports or a shared media here. But all the ports are in the same group, in the same VLAN, like we would call in IT. It's a VLAN 1. It's the management group. This is also the group we use to configure or to address the switch, so we can actually configure the switch, and that's also where the IP interface lives in of this switch. Apart from that, we also see that every port here and in that group has P2P v2, that's this tiny clock icon, is enabled. So if we would like to do separate networks like we just had as an example in the diagram, we have a groups interface. So in GigaCore, there are actually 20 predefined groups and the ISL group. So, and in here, I can just say, I'm going to make a group. I'm going to give it a name, and I can just assign ports to it. I'm going to just leave it like this at the moment, because I'm going to do the same thing from RAVENNA, because it's one step further again. But I'm just showing the interface here, just to make clear. In a management group, for example, we have P2P v2 enabled, end-to-end transparent clock. It's a one-step clock in domain 0. We have out-of-the-box snooping and querying enabled, and the management group uses VLAN ID 1. Once we go to another group, what you can see, oh, it's the name button. If I go into advanced here I see actually the VLAN ID. So normally in an IT switch, you have to set up a VLAN table. So you're going to create a table with different VLAN IDs. In GigaCore, we did this for you. So that's predefined, and we go from VLAN 1 in group 1 to 200, 300, 400, and forward like that. So we skip numbers in between. We had a very good reason, because AVB lives in VLAN 2, so we could not use VLAN 2 to do that. But in every single group, we have these QoS settings for the port set, or we have that to the port set. We have the IGMP snooping in there, and the querying there. If I want to make an inter-switch connection, I can just choose again which connections will become my trunk, and I just assign them. Or, because we have redundancy in place, we can actually say, through our redundant link system, R-links, we can actually know that a particular port is connected to another Luminex GigaCore switch, and we can just retrieve that info by just clicking this button, and it automatically finds out where are my trunk ports. Of course, this is only possible once it is connected. So this is the web UI, and these are connected ports. So we won't retrieve any redundancy information if there's no switch connected, of course. Then when we talk about the different groups, so actually what we do is in a group is we do not only manage the VLAN, but we actually manage a selection of settings that are needed in that particular application. So using groups is really color coding actually your network, and you make a group for AES67, for example, a group for comms, a group for lighting, or whatever you're doing on that network. And by setting the right topics in here, you have, for all the ports you will select, you have these attributes set on the particular ports as well. Before I move back to Araneo, where I'm going to show the full configuration of the switch, I go quickly to one setting on utility, no, on device settings. So here we have the IGMP unknown flooding state. This is actually a bit which is enabled by default in a gigacore switch, because from the moment we start doing networking in the AV industry, we came across quite some applications where multicast and IGMP implementation had some issues, and that sometimes we did not get correct registration. So, and if there was no registration, that's exactly what this bit does. If there is no registration for a particular multicast stream, and a stream like that would arrive to the switch, it will flood it to the network, which means flooding means forwarding it to the connected ports, of course, in that particular VLAN. When we look to applications in broadcast, where we're connecting AES67, for example, into a full-blown broadcast network with Arista switches, for example, as the core switches, we always have to disable this one, because we do not want to have the video streams, which might be even bigger than 1 gigabit, to go to be flooded on the network. And also, often in that situation, we disable the fact that we want to be the carrier in the network. Because one important thing about the carrier is as well that all the multicast data will go up to the carrier in the network. So if you have a network with multiple switches, and if I hover over a port here, I can see in the management group that my carrier is on this switch, on this switch. It's actually indicated on the right of the switch. It means that if there is multicast data from any of these two switches, whether it's known or unknown, it will go up to the carrier, because only the carrier will know if the other side of the network will need that multicast data. So again, if you're once they're using Luminex gigacore switches, for example, in an audio application on the edge of a full broadcast installation, then it's advised that a core switch, we saw applications where Arista, for example, is a core switch, that switch is the carrier, because you do not want to have the video data, the large scale bandwidths with up to 10 gigabit data per stream, for example, to try to be pushed down a link into your gigabit switch. So these are a few things to know. So within that group, in case connected on the edge of a broadcast network, we disable carrier. We still leave snooping on, because we still need snooping, but we disable the carrier, and we make sure that there is no flooding, and assuming in that case that all IGMP implementation is in place. So I'm going to make a quick example here on how I would set up a fully converged network. I have here 3 different switches with a redundant pod. So I have here one redundant link. The dashed line is my redundant link, my backup link. And I can go into configure here, where I have the same similar kind of interface. So I have the pre-populated groups. And I can say, for example, I'm going to change this and make this my AES67 group. And I can say, for example, I want these connectors, and maybe on this switch as well. These 4 connectors, I assign them. And at this moment, they are separated in the network. Let's say these are separated in the network. And at this moment, they can only talk in one switch between each other, because this port 17 will communicate with port 19, here 13, 14, and 15 together, but they're not communicating to each other. For that particular reason, if we want to have the different groups to to be transferred to the different switches, then we need, or the different VLANs here as well, then we need to set up, like we call in IT, the trunk port, or what we say the ISL port. Before I do that, I just make a second group, for example, comms. I'm just gonna apply a few more ports in the comms group, for example. I'll just click a few ports. So I've set up already 2 different applications, and the nice thing about RAVENNA allows you to do this on a multi-connected switches actually. So if, just to show you quickly, if I go back to my network web UI, you see that the changes have been reflected in the web UI as well. So and the names of the groups have been changed in there. So this tool allows me not to just configure one switch, but allows me to configure a converged network directly on a full topology. Also, it will highlight my end devices in a particular color. And the one thing I still need to do is to set up my ISL. I could choose ports in here and click ports again. But as well, like we had in the web interface, we have this retrieve from our redundant link system, RLinks. So I'm going to apply that one, and it asks me if I want to do this on all gigacores at once. Yes, I just want to set up the trunk for everyone. So that's set up. So actually, what happened now is that I have trunk set up between my switches, and that I have directly this, well, you see the color change for this link, so it's not a normal link anymore, but it's indicating a trunk link. I still have my redundancy in place, and this is how we can set up a fully converged network within a gigacore switch, where we already have in the groups we want. For example, I'm going back to my configuration.
Bart, we need to cut it a bit in time.
Yeah, I'm just finishing this off, so I'm just going to say, here we can enable PTP again on that switch, and then we can actually set it up. Just gonna do this again. Oh, it's not taking my. But it allows me to set up every attribute in the group at once. So the tool allows you to configure it, and so it's an easy way of VLANing. And I think, well, this is our way of doing VLANs in groups, and there's other ways doing it in IT, but then you need more IT knowledge. So any questions, feel free to ask.
Right, thank you, Bart, so far. As I can see from the QA, we have no particular questions regarding the Luminex area. And looking at the time, I would definitely prefer to pass it over to Claudia at this time. If something comes up with the particular respect to the Luminex, which we can always discuss it at the end. So from here, we take it to Claudio Becker-Foss from DirectOut. And he was bringing PTP to the boundaries, actually, literally. Claudio is CTO of DirectOut. DirectOut has been founded in 2008 in the middle of Germany, in Mittweida.
Yeah, I wanted to go a bit into details what is behind the situation regarding PTP in the switches, and show you a little bit what actually happens depending on the configuration in the switches. As Andreas pointed out in the beginning, I have the Arte Cora switch here, 1G in this case, and it's currently configured without any PTP configuration in place. So what happens is that with PTP, the sync packets leave the grandmaster, they get into the switch, and the switch needs some time to process them, even if QoS is involved. As Nicolas showed you, it can happen that a packet gets delayed a bit because there was a bigger one a slightly bit earlier and is currently being shipped out. So the sync packet has to wait a little bit until it gets to the device, to the node at the end. And due to this, the sync information will have an offset that is applied to that sync information, to that time information. And as a result, there is jitter introduced into the PTP information. And this jitter or this offset that is added to the sync packet is not the same every time. So it really depends on what's going on in the network, if it's heavily loaded, and what other things are going on. So if we look at the device now, this is the RTOL Quora surface, and you see here the PTP clock. There's no clock instance present right now, so it's really switched off. And if I show you on the device, down here is a jitter graph, and you see every now and then there's a little jump in there, so it's not too bad, but still some jitter introduced. It's not a quite flat line. And if we stay inside the network, having devices talking to each other that are all network synchronized, this might still be fine and not really be an issue. But if you want to synchronize external devices, for instance, with MADI or AES or word clock, so they have a very tight synchronization requirement, in this case, such a PTP situation might cause issues. So what we can do about it is to use the E2E transparent clock. That's the one which is available, for instance, also at the Luminex switch. And as Bart already mentioned, it works in a way that the grandmaster sends out the sync packet to the switch. And of course, still the switch has the same issue. It takes some time to process that packet. And this time might change. However, the switch measures this time, it knows it, and it applies it to the correction field of the outgoing sync packet. As a result, on the receiving node, the time can be corrected, and the synchronization is very accurate and close to what the grandmaster initially sent. And if we apply this now to the Quora switch, we add a new PTP clock here, select E2E transparent, we say save. We can now switch it on certain ports. So I just switch it on the first 8, for instance. And I select the protocol to be multicast. And I have to set the DHCP to 46, which is EF. That's the one which is recommended by AES67. And that is basically it. So now I have the transparent clock in place. If I go to the monitor section of the switch down here to PTP, you can see E2E transparent clock is available now. And if I look at my device, I can see already down here there's a little change at the right where the peaks are reduced, or they are not there anymore, and the jitter graph now smoothens out, so it's significantly changed compared to what we see here on the left with the bigger jumps. And this is just by adding the transparent clock. That is the effect that happens if the switch corrects its own processing time and applies that information in the sync packets going out to the devices. The advantage of this E2E transparent mode is that it doesn't really require to be changed if the grandmaster configuration changes. If we change the, it's agnostic regarding the clock domain or other PTP configuration, sync rate or the like, because it's just taking in whenever a sync packet or a PTP packet comes in, it's just passed through and the correction field is updated, but the switch doesn't care about anything else regarding PTP internally. So this is once this is configured, even if the grandmaster configuration changes, it will stay like that, and you don't have to touch it anymore. Now, what the Quora, for instance, also supports is the boundary clock, and that works a bit different. In this case, the grandmaster sends out the sync packets to the switch, and the switch itself now synchronizes to the grandmaster. So it acts as a slave towards the grandmaster, and then it creates a new clock, the boundary clock, which is sending sync packets to the nodes. So this is a different approach, and the sync information now sent from the grandmaster to the switch is very immediate. There's nothing in between that can really introduce jitter. Same applies for boundary clock to node. This connection is also very immediate. So by that, this the jitter reduction is also achieved, and this will end up with a similar result as the transparent clock. So if we delete the transparent clock here now, we can add an ordinary boundary clock. And now we have to configure a bit more, because we are somehow configuring another grandmaster here. So I switch it on for 8 channels, for instance. Then I define this to be a 2-step clock, and I have to define the clock domain, which I leave at 0 now because my grandmaster is in domain 0, so this is fine. But if I would change the clock domain for some reason in the grandmaster, I had to change this here too. So just to keep that in mind. Again, I go for multicast PTP, and just in case, I set my DSCP code point to 46 again and save my configuration. And now I have to do one other thing, which is setting up the port configuration. In this case, especially the sync interval, which is taken here in its logarithmic value, which is defined in IEEE 1588. So this can be found directly like this in the standard. And the value of -3 translates to a sync value, a sync interval of 8 sync messages per second, 125 millisecond interval, and that is what is actually recommended or required by ST2110, and of course it also works fine for AES67. So this is the information I have to configure here. If I now look at my device, I can see that it became slave again, and it's currently resynchronizing. I have a grandmaster ID, which is a bit different from the one before. You might have not seen that before, but this is actually the grandmaster ID of the switch. So if I look it up here, you can see this is the clock identity, EB4B, right here. Whereas my grandmaster, my real grandmaster of the network, is this grandmaster ID ending with 20004E. And the switch is now in the phase locking state, so it's currently synchronizing to the grandmaster, which takes a bit of time. But after a while, like 30-40 seconds or so, the switch will change over and go into locked state, and in this case, then it's really synchronized to the grandmaster. So now it changed to locked, and I can see this happening here as a result. I have a grandmaster ID change on my device as well. So this changed to the actual grandmaster, 20004E. I still see the IP address of the switch here because it's my boundary clock. So I can see on my device now what is actually my boundary clock and what is my grandmaster. So this is all fine here. And I see also except this jump here where I changed the PTP configuration in the switch, I see the jitter is still fine and is still good. So what is the reason to use actually boundary clock over or to choose boundary clock over E2E transparent clock. Actually, if you look at a bigger setup, this is what I have here is an example. It's still a fairly small setup, but this imagine these devices down here are not 4 or 5, but hundreds. The information going back and forth between the grandmaster is the sync packets are going out from the grandmaster to the devices. Okay, that's multicast and handled by the switches. That's fine, but the delay requests are being sent from every node to the grandmaster all the way up, and they are also multicast, so they are also ending up on all nodes. So all nodes have to cope with hundreds of delay requests, and the grandmaster as well, and has to answer also with delay responses to measure the distance and the latency between, or the delay between the node and the grandmaster to make a proper PTP time calculation in the end. So boundary clock will help here to take this burden off the grandmaster, and now the nodes are just talking to their switch, to their boundary clock, getting the delay requests from there, or the delay responses from there. The switch handles all the delay requests, and it in return only the switch will talk to the grandmaster and measure that distance and that delay there. So this is a good way to spread the load on the network and make the PTP synchronization easier and help to spread the burden of handling all the delay requests. Also, the boundary clock installation, if you have more than one switch in the network, for instance, it helps as a protection if the grandmaster fails. So if the grandmaster goes away, the nodes will not immediately notice that, because they are synchronized to the to their boundary clock, to the switch. And if there are more than one switches in the network, they will negotiate among each other using the best master clock algorithm who is going to be the next grandmaster. One will take over, and they will just stay in sync. The Crowbar 10G even has an oven controlled oscillator on board, so it will very accurately stay in sync until a better grandmaster comes back. And this is a good fallback strategy also, just in case a grandmaster fails. Now, just as a very quick overview, Nicolas already mentioned that regarding QoS, on the Dante AES67 implementation, we have the issue that for the switches, one thing is important to know. The DSCP markings for QoS are different from the AES67 standard recommendation, and the Crowbar switch here offers the opportunity to remap the DSCP information. So there's a translation table here where I can go down and say I want to remap my my EF input to AF41, and then I can apply this to single ports. So I can say I have a Dante device here and another one here, and those get remapped and all the others are taken properly. So in this case, I can fix this overlap of QoS DSCP information, and this can help also to relax the QoS information and make sure we have a proper queuing. We are running a bit out of time, so actually I think there's no real point in showing you that, of course, the Crowbar has a very similar interface to set up QoS and also IGMP. What I find quite helpful just for troubleshooting is, for instance, that to take a look at the IGMP groups information, where you can see immediately which devices have signed up for what IGMP groups. So if a device, for instance, doesn't get any PTP information, I can look here and check, has my device actually on port 4, for instance, subscribed to the PTP multicast address range? No, it has not. So maybe I have an IGMP issue, configuration issue on the device. So this is quite helpful in case you want or you have to troubleshoot your system. Okay, Andreas, I think I hand over back to you for maybe a few minutes Q&A.
Yeah, thank you, Claudio, for this part of the presentation. Unfortunately, we are running out of time here, so I would provide a few more minutes, of course, for some questions. We had some very interesting questions coming in. Roland, before we go, I'd like to thank everybody who stayed with us for the whole time. If you have a few more minutes to spend, just stay online. We will definitely have some interesting questions up to being answered here. Roland.
Okay, yes, yes, some very good questions. First question, is it possible that you can have AES67 streams and Dante streams coexist in the same LAN? He's concerned about PTP version 1 versus PTP version 2.
Right, very quick answer. In principle, yes, we had in the early stages, we had a bit of a trouble with some switches concurrently handling PTP 1 and PTP version 2. By now, since switches can only handle PTP version 1 or version 2, they will transparently forward the other type of packet. So if they are configured to process version 2, they're just forwarding and ignoring PTP version 1. So a PTP switch and an AES67 version 2 environment will not have any benefits for Dante legacy traffic, but in practical, they can coexist on the same network.
Okay, a quick thing for Claudio. I think we can do this while we're answering another question. Is someone's asked if you can just show your last slide again. So regarding the DSCP value 46, does it solve the shared value problem when I run Dante units in AES67 mode?
A very good question, actually. It does not solve the problem per se, because while AES67 has default settings for PTP and audio, where the PTP DSCP settings of AES67 conflict with the audio settings of Dante legacy traffic. In AES67 mode, Dante has not offered the option to change the DSCP values, because they wanted to, most likely they wanted to keep backward compatibility with the legacy installation. So even if you run Dante devices in AES67 mode, that would not solve the conflict between Dante audio and AES67 PTP packets. But of course, there are some ways to solve this problem. One has just been described by Claudio. If your switch offers DSCP remapping, you could at all Dante connected ports remap any Dante audio marked packets to a lower priority. So that would definitely solve the problem. And as far as I know, most of the AES67 equipment, not all, but most, at least I know all the RAVENNA equipment has the ability to also remap any of the DSCP values being used to anything you want them to appear on the network. So either remap at the end devices or reconfigure the end devices, or remap at the switch.
Okay, next question. In a multi-switch setup, would you switch each switch to boundary clock?
Claudio.
Yes, they will all run in the boundary clock mode. It's not necessary, or it's not mandatory. If a switch, you can also mix switches with boundary or transparent clock. But if they support it, it can make sense to switch more of them into a boundary clock mode, and they will. In that case, the grandmaster will talk to a couple of switches, all those that are running in boundary clock mode, to run the delay measurement, delay requests and responses. But all the devices that are connected to those switches in the network, they will just talk to their own switch, and nothing else will spill into the other parts of the network. So by that, you can also make sure that not all devices see all the delay requests of other devices in the network, because the switch doesn't pass them on. It just consumes them, answers them directly peer-to-peer with the device, and all the others yeah, don't see it. So it definitely can make sense to have more than one boundary clock in a network.
Yeah, but in general, it's not required if you have one boundary clock that all the others are in boundary clock mode as well. So boundary clocks are a good measure of, as Claudio said, of balancing the load on the grandmaster. So it might even help if there's just one boundary clock in the system, and then you might have further switches downstream on each of the boundary clock ports which do not have PTP capabilities or just work in transparent clock mode. So there's not a exclusive choice to use boundary clock or transparent mode. They can also be mixed.
Yes.
Okay, thank you. I think a very quick question here that I know the answer to. Is PTP version 2.1 coming to Dante in the future?
Well, glass balling from our side. Unfortunately, we don't have anybody from Audinet here on the call. Regarding PTP version 2.1, this is fully backwards compatible with version 2.0. And from what we learned from Daniel Bold from Meinberg 2 weeks ago on this channel, there are some improvements, but none of those are mandatory or required to continue successfully working with RAVENNA AES67 or 2110. Thus, there is actually no single point which actually would, mandate or require changing to version 2.1, neither in Dante or any other networking solution.
Okay. I think I've got one last question here, which is there a limit between, he's saying hubs, but I think it means hops, between a PTP master clock device and a slave device before the slave device receives an inaccurate clock, so that I have to use, for instance, a boundary clock?
Claudio?
Yeah, well, I don't have an exact figure for that. Maybe you, Andreas, but I think it depends a bit on the implementation on the receiver, and maybe you have to measure whether it can still cope with what comes in, and of course it also has to do or depends on what is going on the network. If there's just a QoS in place and you stack up a couple of switches and it's just maybe 2 or 3 streams going back and forth, that might not be a big deal. But if you load the network heavily, then the jitter increases, and at some point the devices might not be able to lock anymore properly. So there's no exact figure you can say, like after 10 switches it doesn't work anymore, but it depends, I'd say.
Right. There's a good tool for free available from RAVENNA partner Meinberg, the PTP track count, which will give you a good indication how the performance of PTP at particular areas in the network is. So you just hook up a PC with a PTP track count to a particular port on the network, and then you can monitor what is the performance of the PTP protocol. Also, as Claudio showed in his device screen, most devices offer sort of an indication if the PTP they receive is good enough or is in danger of going out of sync, or is even out of sync. So you can't definitely give a fixed number from what number of hops you have to use PTP or not. That highly depends on the situation and network dynamic traffic. Even 1 or 2 switches can be enough to let PTP fail. For example, if QoS is not properly configured, or there are lots of possible causes which could make PTP fail or not.
Okay, and I believe the track count is there's a link to it on the RAVENNA website where there's a whole free tools section, isn't there? Oh,
absolutely. Roland, you just mentioned it. The RAVENNA website offers quite a number of interesting tools. I'll have the link at the end of the presentation. Before we end the presentation for today, for those who stayed on the line, I have a final hint what you should take care of in your network. You probably have heard about energy efficient Ethernet or green Ethernet. Green is good, electrical cars and these kind of things. But in our case, it is evil. Evil, evil, evil. Remember, EEE is evil, 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 because it might save the data transmission to save energy that ruins the clock, and it therefore must be strictly disabled on any network switch which offers this feature. And most of these less expensive managed switches come with EE enabled by default. So that was the final tip at the end. Roland already mentioned we have quite a number of very, very valuable resources and links on the RAVENNA website. I deliberately want to point out one document which touches on the network requirements. That's the network requirements document, which you will always also find on the resources page. And of course, we have further links leading to partner pages with valuable tools like MindWork, etc. That's it for now. Big thank to Claudio, Nicolas, and Bart for joining today's session. And as always, the slide decks will be made available and the recording of the session if you want to recheck anything again or invite colleagues if you find this interesting to also watch this, as with all the other webinars before as well. They are all on the RAVENNA website on the events page. There's the link for the download. Thank you. Enjoy the rest of your afternoon or day wherever you are, and hope to see many of you in 2 weeks again. Thank you, everybody.